Let's get into a couple more formulas that you need to know. So maybe something you're already familiar with. To calculate revenue, which is your income from regular business, you would do X, the number of things you sell, times P, the price that you're selling them for. So if I sell 5 $10 t-shirts, my revenue is $50. That's the amount of money that I get from the customers. And then beyond that, I also would have profit to calculate. So if I had profit, I would think about not just my revenue, which was $50 from selling 5 $10 t-shirts. I would also have to think about the cost that it takes to make the t-shirts. So if it cost me $15 to make those t-shirts, I would take $50, my revenue, and subtract $15, the cost to make them, and say that it was going to give me about a $35 profit. So we want to remember these two formulas. And another thing to remember when you write these out is to give yourself this reminder to distribute. It's going to be X, the number of things you sell, times P, the price you sell them for, which is usually given as a demand equation. So there's multiple things to distribute to. And then typically with profit, the cost function has more than one term. So you want to subtract each term when you're looking at profit as well. So 2 more formulas to know. We're going to look at some revenue and profit things now. So we have our first example is a marketing company has determined that the demand function for 40-inch smart TVs is given by this demand equation here, negative 0.08x plus 600. And again, we're given this domain here. We don't want to tell them that they should make 500,000 40-inch TVs because they're only capable of making between 0 and 15,000. So we're going to keep that in mind when we get our answers, that it must be within that domain, what they're capable of making. So P denotes the units price for the TVs, and X is the quantity demanded. So for the revenue function, the first thing we're going to find, we just need to be able to plug into our formula. So revenue is always X times P, the number of things you sell, times the price you sell them for. And I like to write it with those arrows so that we remember to distribute. So for this revenue function, it's going to be X times our P is negative 0.08x plus 600. So I'm going to distribute here, and our revenue function for this TV company is going to be negative 0.08x times X is going to make it X squared. And then we're going to have plus 600 times X. So there's our revenue function, a formula to know. And then our next thing that we're going to find is marginal revenue. So marginal means take the derivative. So we're going to take the derivative of revenue. So we'll call it R prime of X. Make sure we're labeling all these different functions since now we know cost, revenue, and profit. And I'm going to take the derivative. So I'm going to bring down the power. Negative 0.08 times 2 is going to give me negative 0.16x. And then the derivative of 600x is 600. So there's revenue and marginal revenue, just practicing with our formulas. And the next part says, determine the number of 40-inch smart TVs demanded to produce the maximum revenue. So we want to maximize their daily income from selling TVs, maximize the revenue. Well, we want to remember that to find the maximum of anything, if we want our relative max, we're going to do our 2 steps. Our first step would be find critical numbers. That means we're going to take that derivative and set it equal to 0. We might find 1 or more critical numbers. And 2 is to make a sign chart. We want to make sure we get a max. So on our sign chart, we want to go from a positive derivative, or 0 derivative at our critical number, that would be the soft peak, to a negative derivative. So we don't want to accidentally minimize our revenue, and then we will definitely get fired from our job for doing that. So we want to make sure when we find our critical numbers, we identify the one that is actually going to be a relative max. So our same 2 steps from the last section, we're going to take the derivative and set it equal to 0. Well, we already found the derivative of revenue. We found it above. Marginal revenue was negative 0.16x plus 600. We're going to set that equal to 0. and we want to solve this. It's just a linear equation. It has an mx plus b. So to solve a linear equation, we just want to isolate x by itself. So we are going to subtract 600 from both sides. I'm going to try to get that x term by itself. So we have negative 0.16x equals negative 600. And then we just need to divide both sides by negative 0.16. So I'd grab my calculator and do negative 600 divided by negative 0.16. And I'm getting 3,750 as my x. And remember, x represents the number of smart TVs. So this is smart TVs. That's the ideal production level. That's the critical number according to setting our derivative equal to 0. We just want to double check, is it in that domain that we were given? They can make between 0 and 15,000. So yes, we are good to go with suggesting 3,750. But before we suggest that, we're going to do our second step. We're going to make a sign chart and make sure it's actually a maximum. We don't want to just be giving them a critical number that's not a relative max or a relative min, or something that's actually a relative min. So let's double check this is a relative max. We're going to put our critical number on our sign chart first. This is what makes r prime equal 0. And we just want to test any number before and after. So for before, it might not make too much sense in terms of the problem to test 0, but that's my favorite number to test. Remember, you always plug into the derivative. So I'm going to do negative 0.16 times 0 plus 600. So I'm going to get 0 plus 600, which is positive. So at first, this revenue function was increasing since its derivative was positive. After 3,750, I can test anything I want to. I should probably stick within this domain, so I'm not going to test 20,000, but maybe I'll just test 4,000. Plugging into the derivative, I'm going to do negative 0.16 times 4,000, which is giving me negative 640 plus 600. This is going to be a negative number here. So the original function must have been increasing, it had a critical number, and then it was decreasing. So this is definitely going to be a relative max. So let's make sure we answered the question. Determine the number of 40-inch smart TVs produced to maximize the revenue, and our suggestion is they should produce 3,750 smart TVs. And there we have our little proof as to why. It gives us a relative max. The next part says, well, this is going to be their natural next question. You tell them how many TVs to make to maximize their revenue. Of course, their question right after that is, well, what is our maximum revenue going to be? What's the payout going to look like for this? So we want to plug back into the original function to find this y value. Remember, if you accidentally plug into the derivative, you're going to get 0 because it made the derivative 0. We want to see what is the maximum revenue they're going to get. So I'm looking way back up here to where we found the revenue function. We're going to do negative 0.08 times 3750 squared plus 600 times 3,750. So seeing what the y value of our max is. So just grabbing my calculator, I'm getting $1,125,000 for their maximum revenue. So we would say they should produce 3,750 TVs for a relative max revenue of $1.125 million if we were asked to write a sentence. So there's the revenue side, but remember we just incorporated two new functions. We talked about revenue is X times P, and profit is revenue minus cost. So our next part here is we have a cost function that we're given. So they estimated their total cost, which we don't have to create in this class just because it is an algebra problem to model a cost function, but we're going to use it to find profit. So we want to remember profit is called P of X, and it's revenue minus cost. And we would remember to distribute when we subtract. So for this one, our profit is going to be our revenue minus cost. We need to look way back to where we found the revenue. We said our revenue was this negative 0.08x squared plus 600x. So that's what we're going to use for our revenue function. Negative -0.08 x squared plus 600x minus our cost function, which they give us as 180x plus 200,000. And when you write it like this, you will probably get it wrong. So be super careful. I would always put parentheses on this and write that distributing symbol. So our profit for the x squared term, we just have -0.08 x squared. For our x term, we have 600x minus 180x. So 600 minus 180 is going to give us 420x. And then is it plus 200,000 or is it minus 200,000? We're distributing, so it's minus 200,000. And more importantly, if you plug in 0 to this, your profit for selling 0 TVs after buying this television company or starting it up yourself, your profit should not be positive. If you sell 0 of this, you plug in 0, you would get negative $200,000. They are out $200,000 every time they sell 0 TVs. So that makes more sense than selling 0 TVs and having a plus 200,000 at the end, because you shouldn't have profit off of selling no TVs. So we just practiced plugging into our profit function, and now the next part says find marginal profit. Remember, marginal just means take the derivative. So derivative of -0.08x squared, I'm going to bring down the power. It's going to give me -0.16x. Our mini rule derivative of 420x is just going to be 420. And then the derivative of -200,000 is just 0. And so our last part here, we're going to compute P prime of 100. And the harder part is interpreting what that means. So P prime of 100 means I'm going to do -0.16 times 100 plus 420. And I'm getting 404. I want to remember our output is money for these. X is 100 TVs. Our marginal profit is 404. What does that mean? Remember, marginal approximates actual for the next unit. So we would say the approximate actual profit, because marginal approximates actual. So we'd say the approximate actual profit. Well, when we were doing cost, we would say from making or producing, but for profit, you have to sell. So the approximate actual profit from selling, and it's always the next unit. So the 101st TV is $404. So instead of having to plug in P of 101 minus P of 100 into this long original function, having to plug in both those numbers, P of 101 minus P of 100, we just take the derivative, plug in, and we want to remember marginal approximates actual for the next unit. So this marginal of 100 being 404 means the approximate actual profit from selling just the 101st TV is $404.